Hi and welcome to another look at how we move. Now the other day we did a little activity where we had a trolley move and then we changed the mass or the size of the trolley by adding masses to it. And we kept the same size force on it, the little, as I was calling the little fish, and we saw how it changed. So let's have a closer look at that and what it actually means. Right, the three trials are here. The blue trial was the first one we did, and it was when we started, and it was like the normal trolley. The pink one was when I added some more mass to it, and the green one was when I added lots of mass to it. Alright, so let's see what we found out. This is most important here though. Each of these dots are being measured at the same time interval. So in other words, the time difference between that dot and that dot is exactly the same as between that dot and that dot. So this means we're getting from here. Let's look at the blue one. This is when we started and when I let the mass go, and we actually, here's where we caught it up here. So we can see we've got 1, 2, 3, 4, 5, 6, 7, 8, really 9 times there. Now if we look at the distance that goes apart at these one, that's a little distance, that's a bit bigger, that's a bit bigger, that's a bit bigger, that's a bit bigger, that's a bit bigger still, and we keep getting bigger. So this means our speed is increasing. And all of these show acceleration. So when you see a gap like that from this, we're showing acceleration. So our blue dots were able to, our normal trolley was able to show acceleration. Right, let's see what happens when we add some mass. Right, the pink one over here was when we added that first 250 grams to it. And we did exactly the same thing. Here is where we let it go, and here is where we caught it down here. So let's have a look. We've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So this one had 8 time stamps on it. This one's got 12. So it took this one, with the more mass, it took it longer to travel down the same length. So this means it must have been travelling not as fast. And so if we look at the gaps between our dots again, we see they're gradually getting bigger, so there is some acceleration. But if you look at the size of the gaps here in the blue and the size of the gaps in the pink, the blues are bigger. So in other words, the blue had more acceleration than the pink. The speed changed more. Alright, let's look at what happened when I put both masses on there. Now we've got the trolley, we've got both masses, and we've kept our force the same. And this was on the green. Now let's look at what we've got now. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Right, so it took even longer for this to come down the same track length. So obviously it had less speed. And if we look, we start off them closer together down here. They're getting a little bit further apart up to here. But obviously the distance apart, like on those blue ones, is bigger than on the green ones. Okay, so we're seeing that it makes a bit of difference. So size does matter. And so our conclusion from that would be that if we have something that's got bigger, more mass, more atoms put together, and we use the same size force on it, it's going to be travelling slower. Alright, it's going to have slower acceleration too for the same size force. So from that we can see that the force we put on an object and the object's mass are linked. More about that to come.